Hello, I'm Cole Sanford, Cash Crop Product Specialist for New Holland, and today we are looking at the all-new CR11, a new launch for model year 25. A lot of exciting things with this all-new design. It's a completely ground-up new piece of paper, complete white sheet of paper that we started with the design of this product. And really it revolves around the total cost of harvesting. That is the main thing that we're after. And what actually impacts that? Productivity and losses, total uptime, and those are some of the components that help us get to that lower cost of harvesting. So this machine is equipped with twin 24-inch rotors, horsepower value of about 775 horse with a grain tank capacity of 567. And then an all-new designed residue system that can spread up to 60 feet. We've seen a lot of very exciting feedback from the customers that have been with this machine, and there's all kinds of new technology that are involved to help it create the most productive combine that we've ever built. Starting with the twin rotors, as the crop throw goes through the machine, the feeder width is the same width as the rotors going in for the straight through feeding concept that we've had even back on the TR70 when we first launched the twin rotor combine back in 1975, and this is a continuation of that product. An all new cleaning system has been designed that allows us to not only distribute the material for inclines or slopes, but also for material coming off of the rotors. So there's automatic systems inside the cleaning shoe that allow it to distribute the material based on losses on one side or the other of the machine. Then as the material goes into the residue system, we'll have a couple different configurable options, but we have a system that is actually utilizing radar sensing, so it'll actually be able to sense the position of the residue that gets spread behind the machine and match the width of the header or match the width of the impact of wind. Like if you're going one direction versus the other, it will automatically bias the chaff and the residue to get full coverage, because really the first step of next year's crop starts right there at the residue system of the machine, and we took that into account when we designed and developed the all-new CR11. So as we consider the fourth pillar of the total cost of harvesting, we want to consider the residue system. And that's one of the things that we developed and designed this machine that we had to get right. And one of the things that we saw with this class 10 and up machine, the producers that use that machine are going to be using wider headers. And then we're showing this combine with a 50-foot FD2 that we'll talk about here in a little bit. That when we get into those larger headers, we need to have an equal distribution as well as a header width matched residue system. And so when they were developing the system, they're like, well, how do we actually sense and how do we actually see where the residue is going? Because in the cab where you are located in the machine, you're actually in the wrong side of the machine to really be looking at the residue system. We have cameras and stuff, so they developed a radar system that allows us to sense the material coming out of the residue system and being able to then adjust the residue system on the fly in a closed loop manner such that it gets to the full width of the header. It also is one thing to consider is you could have a residue system that would spread too wide. So if we spread our residue too wide into standing crop, we can actually get losses developed on that next pass because of the material hitting the crop and actually shelling out the wheat. So it's a common thing in our industry you have to watch that. Well, this system watches for that as well. So all we do is input into the system the header width, and then the machine goes to work and basically can change the residue system to meet those needs. Another thing that the system will adapt for is the wind. So as we're driving maybe in a crosswind situation, we need more residue system spread on one side versus the other. This system, because it's only looking at where the actual residue is going, is doing that for us as well. So really doesn't take any operator input, and you can sit in the cab and focus on the things at the front of the machine, knowing that the machine is going to take care of the residue system on the back. So even talking more about the total cost of harvesting, we want to look at, can we hold enough grain for the through that we're trying to do? So as we get into these larger machines and higher capacity and larger headers and higher yields, as our markets are going into those, we need larger grain tanks. So as you can see here on the CR11, it'll be a 567 bushel grain tank. And as you pan and show the unload auger, the grain tank system will unload at 6 bushel a second. So not only does it have a large grain tank storing capacity, but it can unload very quick at a high rate to get more grain out of the system and allow you to really stay in the field at a longer rate. Really, it's part of the design of the machine. You know, we looked at where producers are today and where they'll be tomorrow with their yields. And if you look at that graph going across time, it's increasing. And so we had to increase the grain tank capacity significantly over the flagship CR to handle the larger situations like the larger headers and the higher yields that we're going to run into. All right, so with the CR11 and its insane appetite for capacity, we have to feed it, right? And one of those things that we have here that we're showing on the machine is an FD250. So this is the 50-foot New Holland head by MacDon that we are showing here. And really the biggest thing that you want to consider is the total throughput of the header. In combination with the reel and the deeper belt, allows us to shove more material across the belt and get it fed into the machine. And there's a new knife and guard assembly that has increased the capacity roughly about 20% for the FD1 series MacDon machine. And then they've also improved the ability of the flex, so now we can flex, and as you see on the showroom floor here that we have the lip there designed to kind of show the flex of the header, and it works out really well in showing how the wings move up and down. And that system is controlled by the header, so basically it's a passive system in that regard where the wing pressure allows it to follow the contour of the ground. However, that all feeds back into the subframe, which then allows the combine's feeder house to raise up and down as well as to tilt left and right automatically via the height control system, and gets us a really good razor cut operation in soybean harvest, typically when we're on the ground. Now when we go to wheat harvest with this header, we can still utilize the flex frame that you see here, but we have a series of Contour Master wheels underneath of the machine that allow it to do it with a stubble height included. So I had the opportunity to run a 50-footer there last summer up in Ontario, but it was beautiful what the header was able to do because we were able to utilize the height control system on the combine, the flex of the wings, and we were doing it while still leaving about a 6 to 8 inch stubble height. And that's controlled from the cab, and you can control that height on the fly, which makes a really, for a good operating experience, especially for that shorter wheat or if the wheat is lodged in some situations that you can get into in harvest. So that's a little bit of the taste of what's to come. There'll be more information launched in the future as we get closer to full launch. Again, we'll be starting to take orders later this year for the machine. But if you have more questions and want to learn more about it, visit newholland.com or search New Holland Agriculture on any of the social medias or reach out to your facing local New Holland dealership. Thanks.